welcome to my channel. So in the today's video we are going to discuss the second flow control algorithm, which is go, back and. So this is our second flow control method. In stop and wait, the efficiency was very less. So we just tried to improve the efficiency of stop and wait with the help of the go back and. In stop and wait, if you look at, the sender window size was 1 and the receiver window size was 1. In stop and wait, in a one cycle, sender could send only one packet at a time and receiver could receive only one packet in a cycle. So it is a stop and wait is actually 1 to 1. So only one packet is going to be transmitted in one cycle and only one packet is going to be received by the receiver in one cycle. So the efficiency was very poor in stop and wait. So what we tried, in go back and our sender window size is n and receiver window size is 1. So we try to improve our efficiency. In stop and wait, we were transmitting only one packet in a one cycle. But in go back and we are trying to improve the efficiency by sending more number of packets in one cycle, so that sender remain idle for less amount of time. Sender could remain busy and it could utilize its time. So that is the basic improvement of stop and wait. So now let me give you complete overview of go back and. So let's suppose this is a network. This is one network and this is some another network. We have a routers. There are many number of routers present between the networks. So this is my host. This is host. This is some another host of my friend. Let's suppose Arsh. Okay. So what I want to do, I want to send many number of messages on WhatsApp to my friend. So in stop and wait, what we discussed, we could send only hi message at a time. We can't send many messages unless we get double tick. Double tick is acting like a acknowledgement. So unless we get double tick, we couldn't send more packets to the other party or to the other side. But in this case, our lot of time was wasted in stop and wait. So we try to improve the efficiency of stop and wait. So in this, what we discussed, we have increased the value of sender window size. In stop and wait, sender window size was 1, but now we have improved the sender window size to n. Let's suppose the value of n is 3. The value of n is 3. What does it mean? I can send only 3 messages to the receiver at a time. We have improved our stop and wait. So let's suppose I am sending 3 messages. Hi, what's up? And the third message which I am sending is my YouTube link. So these are the 3 messages which I am sending to my friend Arsh. And each message I am considering as a one packet. So these are the 3 packets which I am sending to the Arsh, to my friend Arsh. And each packet has a sequence numbers like 0, 1 and 2. So this is the window size, the sender window size. The sender window size is 3. So I can send 3 number of packets on the channel at a time. So the maximum number of packets which could be present on the channel is 3. So these are the 3 packets which I am sending to the Arsh. So it is not that all the packets which I am sending will follow the one path. They all might follow the different routes. They might follow the different paths. Okay, so it is not that all might be following the one route. So let's suppose the first packet hi. Hi is the first packet. The first message is moving through this route. The second packet, what's up? This is moving through this path, through this router, and the third, my YouTube link message or packet is moving through this third path. So all these 3 messages, the sender window size is 3. So at a time I can send 3 messages on the channel in a one cycle. So these are the 3 messages which I am sending to my friend Arsh. So and the receiver window size is 1. The receiver window size is 1. So let me tell you one thing. Let's suppose you are sending all these messages to your friend. So there is some particular specific order in which you are sending your messages. Like firstly hi, WhatsApp, then my YouTube link. So this is a one sequence in which you are sending your messages. So what do you expect? The receiver accept all these packets in the similar order the sender is sending. So how receiver is going to expect hi, WhatsApp and the YouTube link. So the similar order in which your sender is sending the message, the same order receiver is going to receive the packets. It is not that receiver is going to receive like this. Firstly, it is going to receive YouTube link, then hi, then WhatsApp. No. The sequence of messages is going to be same in both sender and receiver. Okay. So this is one thing you need to understand. Next, what happens? So the receiver window size is actually 1. 1 is the receiver window size and I am sending 3 messages on the channel. So let's suppose this message got lost. This message got lost in the network or it might get into the looping. It is lost. So now receiver is going to receive this packet. This is packet number 1. This was packet number 0 and this is packet number 2. So now what receiver is receiving or what Arsh is receiving? This message, what's up? This message she is receiving. But it is going to receive all the packets in a sequence. It can't, receive all the packets in a different order. It can receive only one packet at a time and the order in which receiver is going to receive all the packets in a order 0, 1 and 2. But this packet is lost. So receiver is receiving this packet. But receiver is going to discard this packet 1. Receiver will not receive this packet. Why? Because receiver is expecting packet number 0. Receiver is going to receive all the packets in an order in which sender is sending. Like firstly receiver want 0 number packet, then receiver want packet number 1, then receiver need packet number 2. So in a sequence. But our packet number 0 is lost, then receiver is also going to discard these packets. Receiver will refuse getting the packet number 1 and packet number 2. It will say, receiver will say, I need packet number 0. Firstly give me packet number 0, then I will accept packet number 1 and 2. So what receiver will do? Receiver is going to discard the packet number 1 and 2. Then what happens? We will not get acknowledgement back for all these 3 packets within the timeout timer. Then sender is going to again retransmit the entire window. In this, if one packet is discarded, all the coming packets after that particular packet is going to be discarded. If one packet is discarded, all the remaining packets on the channel will going to be discarded. Then what sender has to do? Sender has to send all these 3 packets, the complete window sender has to send in go back and. So 0 number packet 1 and 2, all these 3 packets sender is going to again retransmit. Okay, so let's suppose sender has retransmitted all these 3 packets. Sender has retransmitted all these 3 packets again. This is the retransmitted packets. So now let's suppose receiver want initially packet number 0. Okay, we gave this packet number 0 to receiver. Receiver has received it. Now receiver want packet number 1. Packet number 0 receiver has received. Now receiver need packet number 1. And now we have only two packets on the network. But the maximum number of packets on the channel we can have is 3, as the window size is 3. So what I will be doing? I will be sending the next message. How are you? This is the 4th number packet. The maximum number of packets we can have on the channel is this, 3 packets. So now I have only 2 packets left on the channel. So the next packet which I will be sending is how are you? Okay. So this packet receiver is going to receive now. WhatsApp. Okay. So now receiver need packet number 1. So even if any other message rather than WhatsApp, any other message, how are you, YouTube link, all these messages receiver will not expect, receiver will not accept. Receiver is going to accept only firstly packet number 1, then the remaining packets will be accepted by the receiver. So the maximum number of packets we can have on channel is actually 3. If one packet is received by the receiver, then sender will send one more packet to maintain the 3 number of packets on the channel. So this is actually how go back can work. And if any packet is lost or discarded, then the entire window is going to be discarded. We have to retransmit the entire window in this case of go back and. Okay, so let's find the efficiency of go back and. So firstly let me tell you, this is a sender and this is a receiver. So the sender window size in this case is 3. In stop and wait, sender was sending only 1 packet and after that it was sitting idle. But in this case what happens? Initially sender sent 1 packet. Sender takes some time, it utilizes its time to send the packet number 1 on the channel. Now packet 1 is propagating. Now packet 1 is propagating onto the channel. Now sender is sending second packet. Now packet 1 and packet 2 are propagating on the channel. Now sender is going to send the packet number 3 on the channel. So the more utilization of the link is there in go back and, because in stop and wait after sending 1 packet you are completely sitting idle. But in this case after sending 1 packet the more number of packets are going on the channel and sender is utilizing its time more in case of in comparison to stop and wait. So we have improved our efficiency in this case. So how we can find the efficiency? The efficiency is basically useful time divided by total time. Out of total time, how much time you are going to utilize? is the total time? The total time in this case is similar to the stop and wait. So what is the total time? If you are transmitting one packet, the time it takes to propagate to the receiver and acknowledgement coming back to the receiver. This is actually the total time. In the meanwhile, when your message propagate and you get acknowledgement back, the meanwhile time you are sending some more packets so that you could utilize the sender better. You could utilize the time of sender better. So that is actually your total time. It is actually the time of sending only one packet. That is actually your total time. So what is the total time? Transmission time TT plus TP plus time of acknowledgement plus TP. So this is actually the total time. It is equivalent to sending only one packet, because in the meanwhile time when your packet go to the receiver and you get acknowledgement back, in the meanwhile time you are sending some more packet for the better utilization of the sender. But how much time you are utilizing out of the total time? The transmission time is the time of sending only one packet, but in go back n we are sending n packets. So TT into n. This is our utilization, best utilization of the time of sender. So this is actually TT into n. So out of the total time you are utilizing time n into TT. And if you have to summarize this formula, how you will be doing? I am considering acknowledgement time to be negligible. I am considering the acknowledgement time to be negligible. So TT into n divided by TT plus 2 TP. What I am doing? I am dividing all values by TT. So n divided by 1 plus 2 TP by TT. Or you can say that A is equal to TP by TT and the efficiency is equal to n divided by 1 plus 2A. This is actually your efficiency. That out of the best window size could be 1 plus 2A for the better utilization. But you are sending only n number of packets on the channel. So this is actually your efficiency. We have improved our efficiency as compared to stop and wait. We have increased the number of packets which we are sending on the channel in this case. Okay, so thank you so much for watching my video. If you like my video, please like, share and subscribe my channel.